This video is part 2 of measures of center. So we're going to pick up with the slide where we start talking about mode. Mode, as you will recall, is the data value or values that occur the most. So that means there could be more than one mode. There can be more than one data value that occurs the most. But there can also be no mode at all. So there can be more than one mode, or there can be no mode. And a data set with two modes is called bimodal. And the mode may or may not be the measure of center, or it may not be in the center. So it might be in the center, but it also could be at the very beginning, it could be at the end, it could be anywhere in between the beginning and the middle, or the middle and the end. So it's not necessarily in the center, even though we call it a measure of center. So looking at this example, the number of books checked out from the library from 25 students are as follows. Now, we put these numbers in order to make it easy for you to see how many of each. Looks like there's 3 zeros, 1 1, 1 2, 2 3s, 2 4s, 2 5s, 4 7s, 3 8s, 1 9, 1 10, 2 10s, 2 11s, 2 12s. So it looks like 7 definitely occurs the most. That means the mode is definitely 7. Next, I'm going to introduce a word called resistant. And you've probably heard this word before, but in relation to statistics, it has to do with sensitivity to something called an outlier. A statistic is considered resistant if it is not affected by extreme values. And again, we call extreme values outliers. We'll talk more about that in another video. So the median is resistant, which means it's not affected by extreme values, but mean is not, which means the mean is affected by extreme values. Let's look at this case. There are 5 adults living in a retirement community taking a pottery class. Their ages are 63, 65, 72, 81, and 60. Find the mean and median ages of people taking the class. So the median is 65 and the mean is 68.2. They're not exactly the same, but they're pretty close. So now the instructor's daughter is given special permission to take the class. She is 10 years old. Find the new mean and median age of the class. So now if we add this 10-year-old into the mix, the mean is now 58.5 and the median is 64. Now notice the mean went down from 68.2 to 58.5. That's almost 10 points that it went down. The median stayed close to the same, not exact, but very close to the same. It only went down from 65 to 64. So that shows you that this is an outlier here. It's an extreme value because it is not like the rest of the data. It's much less than the rest of the data, extreme value. And it affects the mean. It pulls that mean down because it's such a small number compared to the others. It pulls the mean down by 10 points, but it doesn't do much of anything to the median. So this is just an illustration of how the median was resistant to that outlier of 10, but the mean was not. Next, we're going to talk about something called skewness and the mean, median, and mode. So there are different shapes of the distribution of our data. One shape is approximately symmetrical. So if we had our histogram, now I know what you're seeing here is not a histogram, but let's say, let me just show you. Draw it like this. So basically, I'm showing you the outline of the histogram here. That's what this curve represents, is the shape that your histogram is making. Okay, so instead of drawing out the whole histogram, we're just going to draw the basic shape of the tops of the histogram. Now, if the data forms a curve, a nice curve that is symmetric, then that means the mean and the median are approximately equal. That's what symmetrical means, is when it's basically the same on the left as it is on the right. If I were to put a mirror right here down the center of this curve, this side would be the mirror image of that side, approximately anyway. So if that happens with your data, if your data forms a histogram in this shape, then you can assume that the mean is approximately equal to the median. Maybe not exactly equal, but very close. Now, if your data is skewed to the right, that means the smaller frequencies are on the right. So we would have our smaller bars. Oops, sorry. Our smaller bars are on the right. This one should have been drawn like that. There. Anyway, the smaller bars would be on the right-hand side, and the larger bars would be on the left-hand side. And so if that happens, then that means that the just want to erase that part there. If that happens, that means that it's skewed to the right, and it means that the mean is greater than the median. Okay, so then we also have something called skewed to the left. That's when the smaller frequencies are on the left-hand side. So if you look over here, the smaller bars would be on the left, larger bars would be on the right. So this is skewed to the left, and if it's skewed to the left, then the mean is smaller than the median. And the reason that the mean is greater in the skewed right and it's less in the skewed left is because if there were any outliers, extreme values for the skewed right, it'd be on the right. It would be an extreme large value, which is going to bring the mean up since it's not resistant. And then if it's a skewed left, it means any outliers would be on the left-hand side, and that would pull the median down. I'm sorry, not the median, it would pull the mean down. So when it's skewed right, mean is greater. When it's skewed left, mean is less. Another word for skewed right would be positively skewed. Another word for skewed left would be negatively skewed. Alright, now check out this example. Is the following data set approximately symmetric or skewed? It's the 2010 Winter Olympic gold medal wins by country. Here's the list of raw data. Here's the data graph. Now if I were to draw this shape of what's going on with this, it looks to me like the smaller ones are on the right, which means I'm thinking that it's skewed right. However, it does look, this side and this side, it's kind of the same except for we have these two larger bars here. So I just want to make sure. So what we're going to do is we're going to find the mean. So if you go into your calculator, you put these data in and you find your mean, you're going to find that the mean is 4.25. And if you put the data in order, or if you use your calculator and you find the median, you're going to see that the median is 3.25. So since the mean is greater than the median, we're going to assume that it is skewed right. Skewed right, which is what we thought it was anyway with the drawing. But if you ever look at the histogram and you can't tell by the shape whether it's skewed left, skewed right, or symmetric, check out the mean and median and see how those compare. Okay, so that is it for this section. And if you have questions, send me an email.